Good morning, students. Welcome to Diamond Group of Institution online classes. Myself, Mohammad Silar. Today we are going to discuss the problems on electromagnetic induction. In the last class, we discussed the three problems. Next one, fourth one. Okay, current in an inductor of 1 millihenry. Okay, current in an inductor of 1 millihenry. We are taking a one inductor. Think, this is a one inductor. Okay, then inductor is denoted by L of current is 1 millihenry is reduced from 5 milliampere to 0. Okay, current is reduced from 5 milliampere to 0 in 1 millisecond. Okay, think, this inductor is connected to a battery or AC source. Okay, then when the inductor is connected to the battery or AC source, then current is flowing in this inductor. Okay, current value is denoted by I. Okay, then in this case, inductor value is given. Current in an inductor 1 millihenry means given data. What is the given value? L equals to, we are writing L equals to 1 millihenry. Milli means how much? What is the power of milli? 10 to the power of minus 3. Then we are writing 1 into 10 to the power of minus 3 Henry. Okay, is reduced from 5 milliampere to 0 in 1 millisecond. करंट का वैल्यू क्या हो रहा? सर्किट्स में डिक्रीज हो रहा. ओके, रिड्यूस हो रहा, डिक्रीज हो रहा. किधर से डिक्रीज हो रहा? 5 milliampere to 0. Then two value is given. In the circuit, current value decreases. First one is 5. Next it becomes 0. 5 to 0 are a current means I1 current. Then we call I2 current. Then we are writing I1 equals to, first one is 5 milliampere. Then 5 into 10 to the power of minus 3 ampere. Then next I2 equals to, what is the value? 0. Then we are adding 0. Okay, then next time is given to decrease or reduce the current in the circuit. Time is given. What is the time here? 1 millisecond means t equals to value is given 1 millisecond. Then we are adding 1 into 10 to the power of minus 3 second. This is the given data in the problem. Okay, suitable value. What are the given data? L value is given, I1 is given, I2 is given, time is given. We are find the EMF induced. How much EMF is induced in the circuit? Means EMF equals to question mark. Induced EMF we are calculating. We write the formula. What is the formula of EMF induced in an inductor? Equals to minus L. Okay, di by dt we are writing. Okay, then equals to minus L. What is di? Change in current. Change in current place mein we are writing I2 minus of I1 divided by dt or t. Substitute the value in this equation or in this formula. We are writing E is equals to minus L. What is the L value here? 1 into 10 to the power of minus 3. We are writing 1 into 10 to the power of minus 3 into I2. What is the I2 value? 0 minus I1. What is the I1 value here? 5 into 10 to the power of minus 3. Sorry, 1 into 10 to the power of minus 3. Okay, 5 into 10 to the power of minus 3 divided by dt. Time value is 1 into 10 to the power of minus 3. Okay, minus 3. Then we are writing 10 to the power of minus 3. 10 to the power of minus 3 is get cancel. Then we are writing equals to minus, okay, 0 minus 5 means we are writing minus 5 10 to the power of minus 3. Then EMF equals to 5 into 10 to the power of minus 3 volt. Okay, or we can write E is equals to 5 millivolt. This is the first one. The next problem, current in a circuit falls from, again current is false or current will be decreasing here. Okay, current in a circuit is falls from 5 milliampere to 0 milliampere in 0.1 second. Okay, in every problems, हर एक problems में 3 points of the first read the question carefully. What is the given data? Write on one side. Okay, which value we are calculating? Second point. Third one, suitable formula used to calculate. Given data to 0 ampere in 0.1 second. If an average EMF of 200 volt is induced, EMF is induced, average EMF is induced 200 volt, gives an estimate of the self inductance of a circuit. We are taking a one self inductance or inductor. This inductor is connected to the battery or AC source. Think this inductor is denoted by L. Current value is decreasing. Decreasing means there are two current value, I1 and I2. In the first case, what is the value? 5 milliampere. Its value is decreased to 0. How much time it is taking? It takes the time is 0.1 second. 0.1 second में ये करंट का वैल्यू 5 एम्पेयर से 0 एम्पेयर हो रहा. कितना सेकेंड्स में? 0.1 सेकेंड्स में. एंड EMF is induced. Circuits में EMF develop हो रहा. How much EMF is developed? E is equals to 200 volt. We are calculating self inductance of a circuit. Means we are calculating what is the L value here. Okay, given data. First write down. Think. Given. What is the value? I1 is given 5 ampere. I2 is given 0 ampere. Time is given, okay, 0.1 second. Average EMF is given equals to 200 volt. Self inductance of a coil L equals to question mark. In this problem we calculate the EMF. In this problem we are calculating the self inductance L value. Okay, then substitute this value in the formula. What is the formula? E is equals to minus L, okay, di by dt. Then E means induced EMF, or one step right down. E equals to minus L, I2 minus I1 divided by dt. Then E equals to what is the value? 200. E value, okay, equals to minus L as it is. I2 value 0, I1 value 5. Then we are adding 0 minus 5 divided by dt. What is the time? 0.1. Then 200 equals to minus L. 0 minus 5 means minus 5 divided by 0.1. ओके, हम टर्म्स को लिखेंगे 200 इंटू 0.1 इक्वल्स टू, ओके, 5 L इंटू 5 और 5 इंटू L. ओके, हम ये 5 को इधर सेंड करेंगे. इट कम्स टू द डिनोमिनेटर. देन इसको मल्टीप्लाई किए तो हमारे को वैल्यूज कितना आता? वी आर राइटिंग, ओके, 5 for the 20, 5 for the 20. देन ऐसे क्या होता है? 0 होता. देन आज इसको दोनों को मल्टीप्लाई करो, कितना होता है हमारे को? 20 इक्वल्स टू L5. देन L इक्वल्स टू 4 Henry. Inductor is denoted by Henry. The next problem, sixth one. A pair of adjacent coil has a mutual, okay, inductance of 1.5 Henry. A pair of adjacent coil has a mutual inductance of 1.5 Henry. Mutual inductance means it has the two coils. We are taking the two coils. Mutual inductance means two coils. We are taking two coils. Think, This is a one coil. Okay, or for example, we are taking this is a one coil and this one is another coil. Think coil 1 and coil 2. Okay, the mutual inductance between the two coils is 1.5 Henry, means given data. Which value is given? M value is given. What is the mutual inductance here? 1.5 Henry between the two coils. Think this is a one coil, this one is another coil. If the current in one coil changes from 0 to 20 ampere in 0.5 सेकेंड, ये दोनों कॉइल में से कौन सा तो एक कॉइल में करंट का वैल्यू क्या हो रहा, चेंज हो रहा. ओके, फॉर एग्जांपल दिस वन कॉइल करंट वैल्यू इज चेंजिंग फ्रॉम 0 अम्पेयर टू 20 अम्पेयर. स्टार्टिंग में इसमें करंट कितना है, I1 इक्वल्स टू वी आर राइटिंग 0 अम्पेयर. नेक्स्ट इसका वैल्यू करंट वैल्यू विल बी चेंज होके कितना हो रहा, वी आर राइटिंग I2 इक्वल्स टू 20 ampere and time value is given 0.5 seconds, means 0.5 seconds में current in the one coil will be changes. Okay, then we are writing in the given data I1 value is given 0 ampere, I2 value is given 20 ampere. Okay, time is given 0.5 second. What is the change in flux? What is the change in flux? Linkage with the other coil. What is the change in magnetic flux? Linkage with the other coil. Change in flux means d phi equals to question mark. In theory concept we discussed the when current is flowing through a conductor, magnetic field is produced. If the current value is changes, then magnetic field value is also changes. These magnetic field lines are linked with the another coil. Okay, what are these? These are the magnetic field lines. Current is flowing in the coil means magnetic field is produced. That magnetic field lines is linked with the another coil. Number of magnetic field lines are passing through the coil means that is called as magnetic flux. How much magnetic flux will be changes because current value is in change. Okay, magnetic flux is a scalar quantity. It has only size but not direction. Then we are writing mutual inductance formulas. हम formulas में लिखा है mutual inductance formula. What is the formula of mutual inductance? E is equals to okay M d I by dt. What is the induced EMF? What is the value of induced EMF? Not given. M mutual inductance value is given 1.5. Di, what is Di? Change in current. Change in current means इसको हम simplify करेंगे. We are writing E equals to M di in place of this one I2 minus I1 by T. But E value दिया क्या हमारे को? नहीं दिया. EMF values दिया क्या? नहीं दिया. Okay. Then in place of this we are writing कौन सा values calculate कर रहे हैं हम? Change in magnetic flux. In Faraday's second law we can write induced EMF equals to E equals to what is the formula? d phi by dt. In place of E we are writing d phi by dt. This time is get cancelled. Then change in flux is equals to M I2 minus of I1. Okay, कुछ नहीं किया हम, just to formulas लिखे. In place of EMF we are writing d phi by dt. Okay, M value is as it is. Change in current, there are two currents I1 and I2, that's why we are writing I2 minus I1. Then dt is as it is. This dt is get cancelled. Then this is the equation. Add this value in this formula. Then we are writing d phi equals to M value is 1.5. Okay, I2 value is 20. I1 value is 0. Then d phi equals to 1.5. 20 minus 0, 20. Okay, then d phi equals to 1.5 into 20. Then we are writing 30. Magnetic flux is measured in Weber. We are writing magnetic flux is measured in Weber. It is denoted by WB. The next problem, okay, a current of 10 ampere in primary coil, okay, of a circuit reduced to zero at a uniform rate in 0.01 second. Okay, if the EMF induced in the secondary coil is 30 volt, EMF induced in the secondary coil is 30 volt. Calculate the mutual inductance of the two coil. We are calculating mutual inductance of the two coil. According to this question, there are two coils. One is primary coil and another one is secondary coil. Then we are writing. For example, think this one is primary coil. Okay, this one is primary coil. Okay, and we are taking one. And this one is secondary coil. Secondary coil. Okay, then secondary coil. Current in a current of 10 ampere. A current of 10 ampere in primary coil is in a circuit reduced to zero. क्या हो रहा? प्राइमरी कॉइल में का करंट डिक्रीज हो रहा. कितना डिक्रीज हो रहा? 10 to 0 means in this primary coil current value is changes or decreases. Starting current is 10 ampere. Next it value will be decrease and becomes 0. How much time it is taking to come 0? Okay, the time is 0.01 second. Then we are ready. Given I1 value is given. I1 equals to 10 ampere. I2 value is given. I2 equals to 0 ampere. Time value is given 0.01 second. If the EMF induced in the secondary coil is 30 volt, when current value is changes, magnetic field is produced. That magnetic field is linked with the secondary coil. Okay, whenever the change in magnetic field or flux linked with the secondary coil, EMF is induced in the secondary coil. How much EMF is induced in the secondary coil? 30 volt. Okay, according to Faraday's law. Okay, whenever the current is changing, magnetic field is also changing. That magnetic field is linked with the secondary coil. Whenever the change in magnetic field linked with the secondary coil means EMF is induced. That EMF is 20 volt, 30 volt. We are writing in the given question. EMF value is 30 volt. Calculate the mutual inductance of the two coils. Mutual inductance. What is the mutual inductance between two coils? We are writing mutual inductance is denoted by M. M equals to question mark. According to question, what is our given data? I1 value is given, I2 value is given, time is given, EMF is given. We are calculating mutual inductance. Then the formula is mutual inductance equals to minus M di by dt. Okay, then EMF E is equals to, we are writing minus M I2 minus I1 by T. Then substitute this value in this problem. We are writing E equals to, what is the value? 30 minus M is as it is. I2 value is 0. I1 value is 10 divided by time value is 0.01 second. Okay, then this term take this side means we are writing 30 into 0.01 equals to minus M. 0 minus 10 means minus 10. Minus minus is get minus into minus means plus. Then we are writing 30 into 0.01 equals to m, okay, then into 10, हमें 30 को इधर सेंड किए तो डिनोमिनेटर फॉर्म में आता, सेंड 30 इज दिस साइड, देन वी आर राइटिंग m equals to 30 into 0.01 divided by 10, 10 ones are 10, 10 threes are 30, then 3 into 0.01 means we are writing 0.03 Henry, 0.03 Henry. The next problem, what is the self inductance of a solenoid? Okay, what is the self inductance of a solenoid? Solenoid means a large number of terms wound closely, okay, and the neighboring terms are closely spaced. For example, we are taking a one, this is a one solenoid, a large number of terms wound and they are closely spaced is called a solenoid, okay. And what is the self inductance of a solenoid? What is the self inductance? Self inductance is denoted by L, okay, of length 0.5. Length of the solenoid is given, small l equals to, we are writing the length of the solenoid small l equals to 0.5 meter, okay. Area of cross section, okay, area value is given, area of this solenoid is A is equals to value is given, okay. And total number of terms is 1000 in this solenoid, number of terms 1000 means given data. What is the given data? First one, length is given, small l equals to 0.5 meter, area of cross section A value is given 0.05 square meter or meter square, okay. Then number of turns n equals to one value is given 1000. We are calculating self inductance of a coil, L equals to question mark, okay. Then self inductance of a coil of a long solenoid, the formula is L equals to, what is the formula? Mu naught, okay, mu naught n a l, this is the formula. What is mu naught? Okay, permeability of free space. What is n? N means number of turns per unit length. What is a area? What is l? Length. Then substitute this value in this case, okay, substitute the value. We are writing how many number of turns? L equals to mu naught, okay. We discussed the V naught by 4 pi is equals to 10 to the power of minus 7, its value. V naught by 4 pi means 10 to the power of minus 7. Send the 4 pi this side means mu naught equals to 4 pi into 10 to the power of minus 7. Then substitute this value in place of this, we are writing 4 pi 10 to the power of minus 7 n number of turns. How many number of turns in per unit length? We are writing number of turns in per unit length, small n equals to capital N by, okay, capital N by L. We are writing 1000 divided by 0.5 means its value is 2000. Its value is 2000. Then we are writing 2000 into area. What is the value of area? 0.05. What is the length value? Okay, 0.5. We add the values. We add these values. Okay. Next, L equals to 4. Pi value is 3.14. Okay, 10 to the power of minus 7. Okay, think 2000 into 0.5. Okay, 1000. then हम इसे लिख सकते हैं, दोनों को मल्टीप्लाई किया तो कितना लिख सकते हैं हम? 1000 into 0.05. okay, then next L equals to 4 into 3.142, 12.56 10 to the power of minus 7. okay, 12.56 into 10 to the power of minus 7. हमें दोनों को टर्म्स को मल्टीप्लाई करना है, मल्टीप्लाई किया तो वर्ड्स कितना आता हमारे को? ओके, पॉइंट का जो शिफ्ट होता 1 2 3 ऐसे शिफ्ट कर सकते हैं हम पॉइंट्स को. देन वी गेट द वैल्यू. देन व्हाट इज द वैल्यू? 1 2 शिफ्ट हो गया समझ लो, नहीं तो इसको ऐसे ही रखो. 1 2 3 1000 इंटू 0.05, हम सभी को एट ए टाइम में मल्टीप्लाई किया तो L इक्वल्स टू 125.600, equations आता. Then 10 to the power of minus 7 we are writing. Then shift the point backside 1 2 3 4. Okay, then we can write L equals to 12.56 10 to the power of 4 digit shift किए plus 4 minus 7 cancel means minus 3. Then in self inductance is measured in Henry, or we are writing L equals to 12.56 milli Henry. Next problem, a long solenoid with 15 turns per centimeter. A long solenoid with 15 turns, okay, 15 turns per centimeter has a small loop. We are taking one long solenoid, and this long solenoid has a how many number of turns? 15 turns. मतलब ऐसा कितना राउंड्स है? 15 राउंड्स है. कितना में? 15 टर्न्स पर सेकेंड. ओके सॉरी, पर सेंटीमीटर. ओके, एक सेंटीमीटर में 15 टर्न्स है. एंड ऑफ स्मॉल एरिया, व्हाट इज द एरिया? 2 सेंटीमीटर स्क्वायर. दिस इज प्लेस्ड इनसाइड एंड normal to the axis of the solenoid. This small loop is placed inside and normal to the axis of the solenoid. Means first one, number of turns is given, capital N by L, given data. Okay, what is the number of turns in this solenoid? 15 turns. Okay, per centimeter means 1 centimeter. We are writing 15 turns per centimeter. Then what is the value here? 15 into 10 to the power of minus 2 लिख सकते हैं हम. ओके, यही ऊपर आया तो कितना होता हमारे को? 1500 लिख सकते हैं व्हाट्सअप, और 10 टू द पावर ऑफ प्लस 2 लिखो, कंफ्यूजन हो. 10 टू द पावर ऑफ प्लस 2. Then next 15 tons and area value is given. What is the area value? 2 centimeter square. This area of this solenoid is A value is given. Okay, 2 centimeter square means 2 into 10 to the power of, okay, minus 2 into centimeter means minus 2. Centimeter square means 10 to the power of minus 4. Area centimeter square 10 to the power of minus 4 meter square is, okay, if a current carried by the solenoid changes steadily from 2 ampere to 4 ampere in 0.1 second. Current value is changing in the circuit. I1 equals to, what is the value? 2 ampere. I2 equals to, what is the value? 4 ampere. How much time it is taking to change the current? 0.1 second. And what is the induced voltage in the loop will the current is changing? What is the induced voltage in the coil or loop when the current is changing? Induced voltage means E equals to question mark. This is our given topic. क्या क्या दिया इसमें हमारे को? Number of turns 15 per centimeter means, that's why we are writing 1 centimeter. Centimeter means 10 to the power of minus 2. Okay, minus 2 को हम ऊपर ले गए तो plus 2, or also we can write 1500 volt लिख सकते. Okay, area of the solenoid is given 2 centimeter square. Centimeter means minus 2, centimeter square means minus 4. Next, I1 I2 time is given. We are calculating the induced voltage in a solenoid. Then we are writing E is equals to, formula is, okay, what is the formula? We are writing E is equals to formula d phi by dt. Okay, induced EF voltage we are calculating, or EMF. Then phi means magnetic flux. Magnetic flux equals to formula B into A. Magnetic flux formula, magnetic field into area. Then we are writing d by dt equals to B into A. What is B? Magnetic field. Magnetic field value is not given. Okay, what is A? Area. But magnetic field of a solenoid, what is the formula of magnetic field of a solenoid? B equals to mu naught Ni. Fourth chapter में रहता है. Okay, we are writing magnetic field B equals to mu naught Ni. What is N? Number of turns per unit length. What is I? Current. What is mu naught? Permeability constant. Okay, we are writing E is equals to B. Okay, take, we are writing d by dt. B equals to, its value is mu naught Ni into A. Mu naught Ni into A. Then E equals to mu naught N. Then we are writing di by dt into A. What is di by dt? Di by dt means change in current by time. Then we are writing E is equals to mu naught value 4 pi 10 to the power of minus 7. Mu naught number of turns per unit length. How many number of turns per unit length? 1500. Okay, di by dt means I2 minus I1 by t. Okay, I2 minus I1 by t. और इधर ही लिखेंगे हम di by dt equals to I2 minus I1 by t. Then di by dt equals to, okay, what is I2 value here? 4. What is I1 value here? 2. 4 minus 2 divided by 0.1. Then we are writing, what is the value? 2 divided by 0.1. Okay, 2 divided by 0.1 means what is the value? 20. Okay, then substitute this value is 20. Okay, area, what is the area value? We are writing 2 into 10 to the power of minus 4. Okay, if we multiply, then we are writing, if you multiply all the terms, then we get, okay, pi value 3.142. If you multiply and we get the value is 753600. हम लिख सकते हैं वर्ड्स. Okay, pi value is 3.142 multiply into 4 into 1500 into 20 into 2. Then we get this one minus 7 minus 4. Then 10 to the power of minus 11. Then equals to, if you are taking the point is backside, then we can write 1 2 3 4 5. Okay, power is decreased. Then 7.53. Okay, 10 to the power of minus 6. EMF is measured in volt. The next problem, a horizontal straight wire 10 meter long, means which value is given? L value is given. Okay, extending from east to west is falling with a speed of 5 meter per second at right angle to the horizontal component of the earth magnetic field. Okay, कौन सा वैल्यू दिया हमारे को? मीटर पर सेकेंड. It is the speed value is given. Okay, 10 meter long, L value is given. Magnetic field, okay, 0.3 10 to the power of minus 4 Weber per meter square. Means कौन सा value दिया है? Given. What is the given data? L equals to 10 meter. Okay, speed, we are writing speed V equals to, what is the speed value? 5 meter per second. Next one, magnetic field B equals to, value is given 0.3 into 10 to the power of minus 4 Weber per meter square. In the first question, what is the instantaneous value of the EMF induced in the wire? Instantaneous value of the EMF induced in the wire or motional EMF, we are writing E equals to question mark. Okay, what is the direction of the EMF and which end of the wire is at higher potential? We are taking a one wire. This wire is falling perpendicular to the magnetic field. ये वायर क्या हो रहा? परपेंडिकुलर टू द मैग्नेटिक फील्ड हो रहा. किधर से फॉल्स हो रहा? ईस्ट टू वेस्ट का साइड में क्या हो रहा? फॉल्स हो रहा. व्हाट इज द स्पीड ऑफ द वायर टू फॉल्स? 5 मीटर पर सेकेंड. दिस इज द वन वायर. दिस वायर इज फॉलिंग फ्रॉम ईस्ट टू वेस्ट. ये वायर ईस्ट से वेस्ट के साइड में फॉल्स हो रहा एंड परपेंडिकुलर टू द मैग्नेटिक फील्ड. मैग्नेटिक फील्ड को ये वायर कैसा है? परपेंडिकुलर है, 90 डिग्री है. Then how much EMF is induced or instantaneous EMF. This problem is on the basis of motional EMF. What is the condition? We are writing first one, E is equals to BLV. It is like formula. B means magnetic field. Magnetic field value is given. What is the value? 0.3 10 to the power of minus 4. L is the length. Length is given 10. V is the speed. Speed value is given. What is the speed value? 5. Then we are writing E equals to 0.3 into 10 means 3. Okay, 3 into 5 means 15. 15 into 10 to the power of minus 4. EMF is measured in volt. Okay, next one. What is the direction of EMF when the fire is falling from east to west? Okay, first which end will be comes in west end. Think this one end means the direction of EMF is okay west to east. We are writing second one. The direction of according to Fleming left hand rule, its direction is west to east. Next one. Which end of the wire is at higher potential? ये दोनों एंड में से कौन सा एंड में हायर पोटेंशियल है? अभी हमारे को ईएमएफ किधर आ रहा? हमारे को वेस्ट एंड के साइड आ रहा. ओके, देन किधर से किधर फ्लो हो रहा? वेस्ट टू ईस्ट फ्लो हो रहा. ओके, मींस वेस्ट एंड इज एट हायर पोटेंशियल. ओके, जिधर पोटेंशियल ज्यादा रहता उधर से ही फ्लो होता. फॉर एग्जांपल, ओके, एक रॉड लेंगे. थिंक दिस इज द रॉड. Okay, this one is end A, this one is end B. Okay, both ends are same temperature. If we are heating the end A, हम end A को heat कर रहे, means the temperature of the end A will be increases. If the temperature is increases means okay, यहाँ पे temperature का values क्या हो रहा है? Increase हो रहा, because हम क्या कर रहे हैं? इसको heat कर रहे. After 5 minutes के बाद में हम इधर touch किए तो क्या होता? Cold feel होता क्या? नहीं feel होता. कैसा feel होता? Hot feel होता. Hot feel होता मतलब what is the meaning? Energy is transferred from higher temperature to lower temperature. The same one. Potential is transferred from higher volt to higher voltage to lower potential. Then we are writing which end is the higher potential? We are writing the higher potential is at west end. West end.